Hi everyone. Today we are going to learn about Form 2 Mathematics, Chapter 4, the topics of Polygon. The learning objective of today is to focus on 4.2, which is interior angles and exterior angles of polygon. Before we go into more details, we have to know how to differentiate interior angles and exterior angles. So interior angles, the words in, it means that the angle formed inside the polygon. So as we can see from here, the picture here, the angle formed at vertex A, vertex B, and vertex C, okay, these are all called as interior angles. However, exterior angles, the word X, it means that outside. When we draw or we extend the straight lines, okay, so the angle formed outside the polygon, so this angle we call as exterior angles. So in Form 2, first of all, in this part, we are going to learn how to derive the formula for the sum of the interior angles of a polygon. Well, I'm sure all of you have already learned before, the sum of the interior angles of a triangle is equal to 180 degrees. Am I correct? But how are we going to prove that? If now, you are given a triangle on your hand, if I want you to tear the triangles into 3 pieces, okay, we tear like this, okay, so the angle formed here, okay, if you add up all together, okay, or you arrange them on the table, so we can find out that actually will form a straight lines, okay, a semicircle will form here, so it means that the angle on a straight line is actually equal to 180 degrees. So we can conclude that the sum of the interior angles for a triangle is actually equal to 180 degrees as well. But what about the other polygon? How are we going to calculate the sum of the interior angle for all these polygons? For example, like quadrilateral, pentagon, hexagon, heptagon, and so on. Don't worry, let's derive the formula together. Let's see the table together. Okay, this table is help us to derive the formula. Okay, so there is a quadrilateral, okay, pentagon and hexagon. So of course we know that quadrilateral got 4 sides, pentagon got 5 sides, hexagon have 6 sides. Okay, so now we are going to see the number of triangles. So let's focus on quadrilateral first. If I cut my quadrilateral like this, okay, so actually it will form 1 and 2 triangles. So the number of triangles is equal to 2. As we already learned before, okay, we already mentioned just now, the sum of the interior angles for a triangle is equal to 180 degrees. So now, a quadrilateral actually is consist by or is formed by 2 triangles. It means that we have to multiply by 2. So we get the sum of the interior angle for quadrilateral is equal to 360 degrees. Okay, let's proceed to the next one, pentagon. So if I cut my pentagon like this, it will form 1, 2, 3 triangles. So we know that a pentagon actually is formed by 3 triangles. As we know, one triangle, the sum of the interior angle is equal to 180 degrees. So 3, we have to multiply by 3. So we will get 540 degrees. Okay, so next, how about hexagon? Same also. We cut it into 1, 2, 3, 4 triangles. So there are 4 triangles, okay? It consists of 4 triangles, okay? So one triangle is equal to 180 degrees. So 4, it means that we have to multiply by 4. So we will get 720 degrees. It's very easy, right? So now, let's observe our results here. Okay, let's observe together. So can you, based on the result, can you make a conjecture? Conjecture means can you make a conclusion based on the observations? So before this, we have to know the relationships between the number of sides and the number of triangles. So if you want to form the formula, okay, so still remember or not in chapter 1, first of all, if you want to form the formula, we have to see the pattern first. So the relationship between the number of sides and number of triangles is very important for us now. Because no matter how, we have to identify the number of the triangle of the polygon first, right? The number of triangle that can be formed by the polygon. Okay, so after that we got it, then we have to multiply with 180 degrees. Then we will definitely get the total sum of the interior angles already. So how are we going to get the number of triangles? 4 become 2, 5, if the number of sides is 5, then the number of triangle will become 3. Number of sides is 6, then the number of triangle will become 4. It means that the relationships, the pattern is what? The pattern is minus 2 to the number of sides. Am I correct? So let's say if the number of sides is n, so we have to use n minus with 2. So we will definitely get the number of triangles. Once we already know number of triangles, so we have to use the number of triangles multiply with 180 degrees. So can you make a conclusion now? So if you want to form the formula, so we use n, okay, because n is number of sides, okay, it keep on changing, right? If I ask you, okay, the polygon with 10 sides, so our n will be 10, okay, so n minus 2, then we have to multiply with 180. So this will be our formula. Okay, in order to find the sum of the interior angle, so we have to use number of sides, which is n, okay, minus with 2, then multiply with 180 degree. Well, once we have formed the formula, now I'm going to use the mathematics software, which is GeoGebra, to show you whether what we have proved or what we have formed is correct or not. So actually, GeoGebra is a very powerful software that can help us to visualize. Okay, can you see that? Okay, this is the triangles. Okay, so the picture shows the interior angles for the triangles. Okay, let's observe the angles here. If I slice the angles, what can you see there? What do you observe? The angle, if I move here, so it will become a straight line. Am I correct? So that's why the sum of the interior angle for triangles must be equal to 180. Okay, because the angle on a straight line actually is equal to semicircle. Semicircle, which is 180 degrees. Okay, so let's observe another one. So let's if I choose pentagon, same also. Okay, this is pentagon. Okay, there are 5 sides. Okay, so let's observe. See the angle? Okay, so now it form one triangle here. So if I pick the angle here and I move the angle here to here, and the angle here come to here. Okay, so it will form what? One triangle. Okay, this is triangles. So the angle formed here is 180. Another one. Second triangle will be formed, right? So the angle formed is 180. the third triangles here. So we will get another 180. Okay. So let's check another one. Okay, let's go to hexagon. Okay, let's see. Let's see the hexagon here. Okay, same also. Okay. If I move like that, one triangle will be formed, right? The second one, third one, fourth one. So it means that hexagon, if the hexagon got 6 sides, am I correct? This hexagon got 6 sides, it means that it can form 4 triangles. And we know that one triangle is 180. So 4 triangles, we must use 180 multiply with 4. Okay, so we will get 720 degrees. Okay, so I wish from the observation here, you can at least learn something and you can visualize it. Okay, so let's try the exercise. Okay, can you find the total sum of interior angles for decagon? How are you going to find? So remember the formula first. N minus 2 multiply with 180 degree. Okay, so decagon actually it consists of 10 sides. Okay, it consists of 10 sides. So N is equal to 10. So how are we going to calculate it? 10 minus 2, we got 8. Then multiply with 180. Okay, so finally we'll get the answer, which is 1440 degree. Okay, so it means that the sum of all the interior angles, okay, the interior angles here, if we sum, we add up all together, we will get 1440 degree. Okay. So another questions. Let's see together. Calculate the value x for the following polygons. So the total sum, as we know, the total sum of the interior angle is x or n minus 2, then multiply with 180 degree. So based on the diagram here, we know that this is pentagon. Okay, pentagon. So pentagon, we know it's already given to us the other angles, just left once. So first of all, we have to know the sum of the interior angles for pentagon. Okay, so how are we going to calculate? 5 minus 2 multiply with 180. So afterwards, okay, 5 minus 2, it means that it forms 3 triangles. 3 multiply with 180, then we get 540 degree. It means that all the angles here, if we sum up together, we will get 540. So now, can you calculate what is the value for x? Of course, we just use 540 degree. We minus the angle here, which is 90, minus 60, minus 130, and the last one, minus 100. So we will get 160 degree. Okay. So if okay, then we are going to proceed to the exterior angles. Okay, the sum of how are we going to in this chapter, in this topic, we are going to make and verify the conjectures, okay, about the sum of the exterior angle of a polygon. So before we start, same also, I just want to let you guys to observe the animations. Let's see together. Okay, I start from triangle first, because triangle is very easy, right? Okay, so now I don't want interior angle already. I will pick shows the exterior angle. So this will be the exterior angle for triangles. So when we extend the straight lines. So you can see that the angle formed here will be exterior angle. Extend it, the angle form exterior angle. Okay, extend the lines here, so we will get exterior angles. Okay, so it means that triangle got 3 interior angle and also 3 exterior angles. So let's observe together. Okay, what is the changes of the angles? If I move the angles like this, so what will it form? It will form a circle. Am I correct? Okay, so we know already, the exterior angle will form a circle. So what is the angle for a circle? 360. So we can conclude that the sum of the exterior angle for the triangle is equal to 360. Okay, so let's see another one. Okay, let's observe another one. Let's choose pentagon. Okay, sorry, pentagon. Okay. This is pentagon. So now click shows the exterior angle. So pentagon got 5 exterior angle. So now let's check what happened. Please observe. So what will you get? The sum of the exterior angle for pentagon will be a circle, which is 360 degree as well. Am I correct? Okay. Now, let's observe another one. Let's pick heptagon. Okay. What will happen if we choose heptagon? Okay, this is heptagon. So let's choose shows the exterior angle. So observe now. What will you get? It will form a circle as well, which is 360. Okay. So, can you see the similarity? Let's choose another one. Okay, I try another patterns. Okay, I choose octagon. Okay. This is another patterns to show it. Okay, this is octagon. We know that. Okay, got 8 sides. Of course, we know there are 8 exterior angle as well. Okay, so please observe. If I make my octagon become smaller, smaller, smaller and smaller, okay, let's observe together what will happen. It will become a circle as well, right? So what is the sum of the measure of exterior angle of an octagon? Of course, we know that it is 360 as well. Okay, do you see that? Okay, so after you observe so many examples already, okay, now let's go back to our slides. Can you make a conclusion? Can you make a conclusion or make a conjectures based on your observation just now? We know that the sum of the exterior angle of polygon is equal to 360 degree. Okay. So no matter what polygon, okay, the sum of the exterior angle of polygon must be equal to 360 degree. Must remember. Okay. So now let's see the example, the questions. Okay, calculate the value of x for the diagram below. So of course, if we see these questions, of course you can find the interior angle first, right? Because this is straight line, we know that. So 180 minus 120, so you get this, and then you will get this. So afterwards, okay, the sum of the interior angle 180 minus this angle and this angle, you will get this angle, right? So afterwards, you use 180 minus this angle. Okay, so you will get x. Okay, but it's very complicated, right? So if you already know the sum of the exterior angle of the polygon is equal to 360, so we can see that this is exterior angle, this is exterior angle, this is another exterior angle. So in order to find x, we just need to use 360 minus 120 degree and minus 160. Okay, so that you will get 80 degree. Okay, so very easily, right? As long as you remember the sum of the, you have to remember sum of the exterior angle of polygon must be equal to 360 degree. Okay, now let's proceed to another questions. Okay, these questions. Calculate the value x. Okay, this is value x. Okay, for the diagram below, given that AB equal to BC and it's equal to CD and equal to DE and also EF. So from this information, we know that ABCDE actually is a regular pentagon because all the sides are equal. Since we already know that all the sides are equal, it means that all the interior angle must be equal as well. And same also to the exterior angles. Okay, all the exterior angle must be equal because it is a regular pentagon. Since we already know that the sum of all the interior angles, no matter is what polygon also, it must be equal to 360 degree. Okay, then now we know this is pentagon. So if we want to find one of the exterior angle, we just need to use 360 degree divides by n. N is, it means that the number of sides. Okay, so we just use 360 degree divides by 5. So we will get 72. And 72 degree is actually the exterior angle for a pentagon. So here will be 72. Okay, same also, this is exterior angle. So if in order to find x, we know that this is a triangle. The sum of the interior angle for triangle will be equal to 180 degree. So if we want to find x, we just need to use 180 minus 72, one of the angle here, and then minus 72, another 72 here. So we will get 36 degree. So this will be our x. So very easy only, right? Okay, so actually that's all for today. But before we finish, okay, I wish you guys can answer these two questions first. First, what is the formula for the total sum of interior angles of a polygon? Another one, what is the total sum of exterior angle of a polygon? So the first questions, we know that. What is the formula? N minus 2 multiply with 180 degree. Second questions, what is the total sum of exterior angle of a polygon? So we know that no matter what shape, okay, as long as it's polygon, so the sum of the exterior angle must be equal to 360 degree. Okay, so same also, there's one tips here. If the exterior angles of a regular polygon, okay, regular polygon means it means that all the sides must be equal. Okay, the length of the side must be equal, so that all the exterior angle must be equal as well. So we just need to use 360 degree divides by the number of sides. Then you will get the exterior angle of a regular polygon. Okay, so that's all for today. I hope you enjoy the video. Thank you.